My name is Bill Groot. I'm an adjunct professor with the University of Toronto and retired forest fire research scientist with the Canadian Forest Service. Today I'm going to talk about sampling surface fuels, and I'll start out talking about the applications of fuels data and the types of fuel sampling that we do, and then I'll get into the details of how you sample different fuel layers, and I will end the talk talking about how fuels are used to calculate fire behavior. And fuels are information is calculated for a number of reasons, but it usually comes down to fire behavior. So fuels data can be collected to assess the fire risk or potential around, for instance, a community or generally at the landscape level. Fuels data can be used to develop a prescribed burn prediction. It can also be used to predict fire effects, such as carbon emissions, depth of burn, or correlating mortality regeneration to fire behavior characteristics. And fuels data can be used to develop new fire behavior models as well. So the first question we ask ourselves is, well, what do we sample? And the simple answer is we sample what burns. So you wouldn't sample things that you know really aren't going to burn or contribute fuels to a fire. So for example, if you know that the depth of burn is only going to be a few centimeters and you have a deep organic site, you wouldn't be sampling for bulk density 40 centimeters down. So you reduce the amount of fuels that you need to sample. If you're unsure whether or not something is going to burn, you would sample it just in case. So the different layers that you would sample are the organic forest floor fuel layer, which includes litter, fermentation, and humus layers, as well as lichens and moss, herbaceous plants, dead and down woody debris, shrubs, and vegetation, or regeneration. And that would be trees that are less than diameter breast height. So the first type of sampling that we do is for fuel moisture, and we sample this using metal containers. We typically sample uh, moisture content for fine fuels, and that's because fire spreads through fine fuels, and fine fuels change their moisture content very quickly. They're constantly exchanging moisture with the environment. And we would normally sample fuels like litter, needles, lichens, and moss immediately before we would do a burn. And then we would seal these containers with a metal lid and tape around the edges so that the moisture stays within the container. And then we would oven dry these, open the containers up, oven dry them uh, until the samples reach a constant weight, which usually takes 1 to 2 days at 70 degrees Celsius. It's good practice to dry samples at 70 degrees Celsius because if you dry at a higher temperature, like 100 degrees, for live material like needles, you would be driving off volatiles, which is part of the weight that you're wanting to measure in those fuels. The other type of fuel sampling we do is for fuel load. For herbaceous plants, we would do this using clip plots. For regeneration, you could use basal diameter measurements if there are biomass algorithms available for those tree species. Usually there isn't. Usually tree biomass algorithms begin at dBH height. If you want to sample for biomass of regeneration, you can do destructive sampling, clipping. In an experimental burn, we would typically do destructive sampling outside of the plot so that we minimize the impact of the burn plot itself, any disturbance to the plot. So you would do clipping and develop a correlation between the basal stem diameter and the amount of biomass to that seedling. And so you could develop new algorithms for the area that you're burning in. Shrubs, not often sampled, usually because they are either a species that really doesn't contribute fuel to a fire, like, for instance, willow, which it may be part of the burn, but um, at most it might just scorch the leaves and there really isn't a fuel contribution to the fire. Or because shrubs are so sparse that they really don't have much fuel to contribute to the fire. However, if you do have a case where there's a substantial amount of fuels and you want to know what the biomass is, you probably have to develop your own algorithms that could be done, again, correlating basal stem diameter with the biomass of the parts that you clip. But you also need to develop fuel consumption models, and that's something we don't have in Canada, is good fuel consumption models for shrubs. But you can develop your own models as well, again, doing the clipping and then correlating that with basal stem diameter with biomass or with canopy volume measurements with biomass. So you would measure each individual shrub as a cylinder. So there's a diameter to the size of the crown and a height, and you would get biomass from that. So the other two layers left to sample are forest floor and dead woody debris. And Alberta has a field sampling manual that describes how to do this. Different provinces use different approaches, but the same techniques. So a line intersect method is always used for um, determining dead woody debris fuel loads. And normally fuel forest floor sampling is done along the transect as well. So in Alberta, there are 4 transects of 25 meters that are laid out in a cross pattern to collect this information. And with dead woody debris sampling, it's really about partitioning all the fuels into different diameter classes. So size classes 1 to 5 would be for pieces of dead woody debris that are under 7 centimeters in diameter. And then there's 2 classes for pieces that are greater than 7 centimeters in diameter, and that is by sound and rotten uh, categories. So for the fine and medium woody debris pieces, which is less than 7 centimeters, you would lay out this transect, and any piece that falls under the line that is less than 7 centimeters, you would just determine what size class is it in, and you would use a Gono gauge uh, to estimate that. And so it's simply counting the number of size pieces in each of those classes. For coarse woody debris, which is greater than 7 centimeters, you would measure every piece with calipers, and then you would classify each piece as rotten or sound. And the Alberta manual has a good description of how to classify decomposition. So once you've collected the data, you can then calculate the fuel load using this equation. And the weight of the fuel is determined by the specific gravity of the species that you're measuring, the tilt angle of the piece, the number of intersections, the diameter of those pieces, and the slope of the transect line and the length of the line. Fortunately for here in Alberta, there's a few studies that have been done that greatly reduce the complexity of those calculations. Work done by Ian Nalder and others came up with a set of simplified factors that could be used in the boreal forest region for size classes 1 to 5. Delisle and Woodard have another equation that has some factors that can be used in the montane region. And Bessie and Johnson also has some specific gravity values for species in the subalpine region. So in Alberta, I would recommend going from this original equation to this simplified equation by Nalder for size classes 1 to 5, where they use an M factor. For pieces that are greater than 7 centimeter or size classes 6, sound and rotten, I would use this equation you can find in Delisle and Woodard, where it uses the summation of the diameter squared of the large pieces, the specific gravity, and the slope of the line and the length of the line. So that's how you calculate fuel load. Usually what you want to know, though, is what the fuel consumption is. And so how do you measure fuel consumption? Well, it's simply a matter of resampling those exact same transect lines after the fire and comparing that to the amount of fuel that you have before the fire to what's left afterwards. For the coarse woody debris pieces on the original line transect before the burn, you would install a nail at the point where the transect line crosses the wood. And that's because during the fire, a log will move a little bit. And by having a nail in there, you'll be able to measure the exact same spot that you measured it before the fire. So forest floor fuel sampling. Along these 25-meter transects, there are 5 points where forest floor depth is measured and 2 points where samples are taken. If you were doing an experimental burn, you would do these samplings of the forest floor outside of the plot, again, to minimize the disturbance that you would create to the plot that you're planning to burn. So along those 25-meter transects, there's 2 points where you do forest floor sampling. And what we would do is extract a monolith of organic soil. So you would cut down usually about 15 centimeters square down to mineral soil, and then you would carve it off in layers, separating by litter, moss, the F layer, and the H layer. And if any of those layers are greater than 2 centimeters, you would separate it by 2 centimeter layers in between. Then you oven dry all of those layers, and you have a nice description of the bulk density by depth for the forest floor layer. And that information is used to determine fuel consumption. So before the burn, we would install these depth of burn pins where there's a horizontal bar that is placed at the top of the surface organic forest floor fuel layer. After the burn goes through, we go in and resample. We measure down from those horizontal bars to determine what the depth of burn is. And then we can correlate the depth of burn with the bulk density samples for those depths. This picture here shows pins that were set on matted grass because we were measuring the depth of matted grass that was burned. So that's how you get fuels and fuel consumption. How do you use this with fire behavior? Well, two things that are usually wanted to be known about a fire is, number one, is it going to be a surface fire or a crown fire? And secondly, what is the overall head fire intensity of that fire? So the surface fuels data are used to calculate the critical surface fire intensity, which will determine whether it's a surface fire or a crown fire. And to do that, you need an estimate of what the surface fuel consumption is, what the live crown base height is of the trees, and the foliar moisture content of the needles on those trees. If the fire does become a crown fire, we use the surface fuel consumption plus the crown fuel consumption to calculate the overall head fire intensity. I won't go into the details of how we calculate this, but there are prediction tools and models available to help you do this. One of them would be the Canadian Fire Effects model, which has a web version, a PC version, and an Excel version. And as a quick summary, I think most people are probably familiar with the structure of the Canadian Forest Fire Danger Rating System. There's the FBP system, but it has 16 distinct fuel types, but you can't adjust any of the fuels information in the FBP system as it stands now. There is a next generation system, FBP system, that's being worked on, but it won't be available for about 5 years or so. In the meantime, you can use CANFIRE, which is a model, an integrated science management model that resides outside of the FBP or the danger rating system, and it's driven by information from the FWI system, as well as rate of spread algorithms from the FBP system. And the third driver is fuels information or forest inventory that's input into CANFIRE. So in effect, what CANFIRE is doing is allowing you to use fuels information with the FBP system. And the output is that it provides information on fire behavior, rate of spread, fuel consumption, fire intensity, and type of fire, as well as physical and ecological fire effects. So that gives you an overview of why we sample fuels, how we sample fuels, and how we use it to calculate fire behavior. Thank you very much.